Alright guys, it's time to start actually solving logarithms. Really not that bad. It's kind of a combination of the last two videos. We do have to be careful though as we get into this, simply because you have to remember that the domain of logs has to be greater than 0. So if you get any negative answers or any zeros when you plug them back into your original equation, those are not solutions. They're extraneous answers. So let's just dive in. I have a pretty straightforward example here, ln of 2x equals 5. There's two ways to actually solve this. I'm going to solve it by changing ln to log base e. I will show another way as well underneath it. So I showed most of you guys to change ln to log base e of 2x equals 5. And then from here, you write this as the exponential function. Use your scorpion tail to get rid of the log. When you do the scorpion tail, your log goes away because you're doing the formal definition of logs. So you get 2x equals e to the power of 5. From here, this just simply becomes an algebra 1 question. How do you solve for x? You divide both sides by 2. Therefore, x equals e, keep in mind it's 2.71, Euler's constant. It's a number. E to the 5th divided by 2, which is approximately 74.21. The other way to actually solve this is that you could e both sides, because there's a property that says e to the ln of x equals x. And of course, with the rules of algebra, what you do to one side, you must do to the other. So here we go. If we have ln of 2x equals 5, we can e both sides. Well, e to the ln of 2x, using the property right up here, is just simply going to be 2x equals e to the 5th power, which you see that this and this, actually the step right above it, this, they're the same thing. So then you don't have to see the rest of it. It's going to solve out to be the same thing. All right, let's look at the other side. This other problem. Log 10 plus log 2x equals 2. Now here, this is a common log. I didn't write a base on there because it's understood to be 10. So first thing we need to do is we need to write this as a single log. So we need to condense. And if you think back to the past couple videos, when you do log x plus log 2x, the plus really means multiplication. So we can write this as log of x times 2x equals 2. Here, of course, x times 2x will get log, I want to write my 10 down here, of 2x squared equals 2. We can do the scorpion tail trick. And when we do that, the log completely goes away. So we have 2x squared equals 10 squared. Of course, 10 squared is 100. So we get 2x squared equals 100. Divide both sides by 2. We get x squared equals 50. And of course, you take the square root of both sides. And when you take the square root, you must do the plus or minus because it is ambiguous. So we're going to do plus or minus the square root of 50. Make sure you break down the square root of 50. 2 goes into 50 25 times. And of course, 25 breaks down to 5 and 5. And remember, if it has a pair, it can go outside and play. If it's alone, it stays inside the house. So my x equals plus or minus 5 square root 2. Now here, make sure you go back and plug these in because you're going to have a positive answer and a negative answer. So if I plug these in, I'm going to have log, I can do negative 5 square root of 2. Well, right off the bat, I see a problem because this part right here has to be greater than 0. So that is not an actual real solution to this. The only solution to this is when it's going to be positive. So my answer would be 5 square root 2. You must absolutely remember to go back in and plug them into your original equation and do the math. Because even if you have a negative number, but you plug it back into the equation and the result ends up being positive, so you have a positive number for a logarithm, that would still be a solution. You can't assume all negative numbers are not solutions. You have to go back and plug them into the original equation.